Okay, the first lesson in Unit 8, Rational Exponents and Radical Functions, is to be able to evaluate roots and use rational exponents. So the first thing that I want to talk about, I just want to note a couple of things. So we should know by this point that 2 cubed equals 8, which means that 2 is the cubed root of 8. So since 2 cubed equals 8, that means the cubed root of 8 equals 2, okay? 2 to the 4th equals 16, so 2 is the 4th root of 16. So the 4th root of 16 equals 2. 2 to the 5th equals 32, which means 2 is the 5th root of 32. So we could write 5th root of 32 equals 2. So hopefully you kind of get the point. Then 2 to the 6th would be 64. So the 6th root of 64 would equal 2. So this gives us a general rule for roots. If I have something raised to the n power equals a, then b, whatever that number is what we call the nth root of a. And hopefully that will make a little more sense here in just a second. The nth root of a we write like this, where n is called the index. So one thing that's going to be important for you to be able to do is to go from basically exponent form into radical form. And so if a radical looks like this, so like square root of a, then the rational exponent form of that would be a to the 1/2 power. If we were talking about the cubed root of a, then we would say a to the 1/3 power. The 4th root of a, we would say a to the 1/4 power. So here's the rule, and this is the part you're going to want to make sure you write down. For whatever your index is, whatever root you're taking of a, you're going to write that as a to the 1 over your index power. This is for any integer greater than 1. So here's your rule. Make sure you write that down. Okay, so we're going to evaluate a couple of things, and usually evaluating just means you're going to get a numerical answer. So the first one I want us to do is the cubed root of 8. So what times itself 3 times gives us 8? Well, we know that's 2. Okay, so let's think about if we did the cubed root of -8. Now, when we talked about square roots, if we took a square root of a negative number, that introduced an I. But when we talk about cube roots, because a negative times a negative times a negative actually does equal a negative, the cube root of -8 isn't any imaginary number, it's just -2. So as a side note, this is because -2 times -2 times -2 equals -8. Okay, you're going to definitely want to make sure you write this next part down in your notes. If we are talking about the nth root of a, so on all of these, we're talking about the nth root of a. If we're talking about even roots, so even roots, if n is even, and we're doing the nth root of a, if a is less than 0, so if a is negative, then we are going to have no real nth roots. So this is just like if you took a square root of a negative number, we got imaginary numbers. They weren't real. If a equals 0, then we get 1 real root, because the square root of 0 or any nth root of 0 is 0. And if a is positive, then you're going to get 2 real nth roots. So use this to kind of, help you to use square roots to help you understand this. This is just like if we took the square root of 16, we get plus or minus 4. So that's why we have 2 real nth roots. Okay. Now for odd roots, if a is negative, so for nth roots of a again, if a is negative, you're going to have 1 real nth root. So as an example, cubed root of -8 is -2. There's our real nth root, our real third root. If a equals 0, you're going to have 1 real nth root. So same as on the other side. If we took the cube root of 0, it just equals 0. And if a is positive, then we're going to have 1 real nth root. So no matter what, if we're talking about an odd root, we're always going to have 1 real nth root. So cubed root of 8, for instance, is just 2. Not 2 or -2, just 2. One of your 2.0 objectives in this unit is to be able to convert between rational exponent and radical notation. And so this is how you do that. So if we have some number and we're taking the nth root of it and we're raising that to the m power, and I know that these variables sometimes get a little confusing, but just remember all of them just represent numbers. This is going to equal a to the 1 over n. Remember we talked about that in an earlier slide, raised to the m power. And remember when we do this and we have a power raised to a power, we multiply our power. So 1 over n times m is just m over n, like that. So this is how we convert from here to here. And we can go the opposite way. If you had a -1, so let's say we started here, you're going to do the exact same thing. We would start by moving that down to the denominator, and then we would write that as 1 over, like this. Okay? Okay, so let's start by rewriting in rational exponent notation. So we are going to start in radical notation, and we're going to take it into the fractional exponent. So if we started with, let's say, 15, the cube root of 15 squared, then we would rewrite this. This index right here is always going to be in our denominator, and this is always going to be in our numerator, so 15 to the 2/3 power. If we were doing, let's say, 20, the 4th root of 20 to the 7th power, then we would do 20 to the 7 over 4. Index is always in the denominator. That's a 2.0 objective right there, to be able to go between those two forms. So this number always goes in the denominator, and this one always goes in the numerator. You'll also see it like this, where you're supposed to rewrite in radical notation. So let's say we started with like 7 to the 2/3 power. Now remember that bottom number is your index, so that's going to go here. 7 is our base, so it's going to be inside the radical, and then we're going to raise that to the numerator's power, so to the 2nd power. You could also write it like this. Either way, that power can be raised to the whole thing or just to the 7. Both of those are equivalent. So if we had like 5 to the 5 over 4 power, it'd be the 4th root of 5 raised to the 5th power. Okay? Okay, another 2.0 objective is to be able to approximate roots with a calculator. So if you had, for instance, like 10 to the 2/3 power, you would just type that in as 10 caret 2 divided by 3, and you would want to put that in parentheses like that. So we'll do that. 10 caret parentheses 2 divided by 3 would give us 4.64. I use this symbol because this means approximately. I rounded this to 2 decimals, so this isn't an exact answer. Now on your all's calculators, you may or may not need the parentheses. If it moves it up into the power position, you probably won't need those parentheses. So let's do one more. If we had 7 to the 1/4 power, we just do 7 caret 1 divided by 4. Maybe need parentheses around those, just depends. And we would approximate that to 2 decimals, so 1.63. If you were typing in, for instance, this, you're going to type it in just like you see it. And actually, let's make this a different index. Let's make that 5. So we'll do 5th root of 5, which is not 1, by the way. So to do this on your calculator, you're going to do parentheses, and then you're going to hit the number 5 go to math, and then go down to the fifth option, and then that will make the fifth root. And then we'll put in 5. You'll have to hit the right cursor button to get out from underneath the radical. Then you'll hit another parentheses, caret, to bring it up to the power squared. So this would be 1.90. So try that on your calculator a few times until you get that correct value. And I'll do one more and I'll kind of walk you through the process. If we did this one, we would do parentheses. We'd hit the number 7 for our index. We'd go to math, down to the fifth option. We'd type in our 6 for our base. Hit the right cursor to get out from underneath the radical. Close your parentheses, raise to the third power. And you should get 2.16 on this one. So just play around with that a little bit and see if you can get the correct values. That's really it for this first lesson, is approximating and converting between the radicals. I'll have a short practice for you that I want you to complete, and then you'll be all set to move on to the little bit harder stuff. Thank you.